Cool. So another club meeting today. If you read the email and if you saw any of the links I added, we'll be going over an actual piece of relevant malware that's being used today. It's actually discovered by a pretty relevant malware research team that publishes most of their findings on Twitter and sometimes on the blog page for Bleeping Computer. And it's the Malware Hunter team. The piece of malware that they found in particular is the Abbadon RAT, and that's a remote access Trojan. And the interesting thing about this in particular is that it uses Discord as a C2. So sometimes you see things like people using like Empire shells or Metasploit, and it sort of connects back to the command and control that way. But it's sort of interesting that you're seeing, a trend as you see more social media being used, and especially social media like Discord, where you can share files, or like with Messenger, that you can host your malware and then you can just sort of share those links to the file that's been uploaded, and you can use Discord to sort of, what's the word, circulate and host your malicious files. And you can kind of see in other previous articles by Bleeping Computer just the trend of how people have been trying to abuse and exploit the services that Discord offers. And it varies between just using Discord as a host, like I said, or by actually modifying the Discord client to act as a Trojan. And if you're familiar with using Discord, it uses something like the Nitro services. I don't know if maybe I probably should have looked this up beforehand, but so Discord is just like an Electron app that runs on JavaScript. So you can see that here, like with user styles, and it's also evident because you can run Discord in your browser. It works similar to like Slack. So they're programs initially written in JavaScript and meant to be used in a browser, but then you can repackage the web app as an Electron app, which basically just like packages a version of the browser with the website and then allows the client to run it locally on their machine. Hey, Joey. I don't know if you saw the previous email, but we're just real quick to get you caught up. We're talking today about a remote access Trojan that uses Discord as a C2. So, for communications between the client and then the malicious actor from, their server. And we're just talking about how, the different trends as Discord is going from more malicious attacks against the client itself to using it as an active, C2. Like with, maybe you might be familiar with like WordPress. Sometimes criminals will take advantage of the exploits within WordPress and the different plugins you can load into it. I don't know if that's the same thing with Discord and how you can use bots, but because those exploits, privilege escalation, they'll get access to the WordPress site, and then they can use that to host their, different malware and spread it, throughout the internet. But it's sort of the same concept with Discord and the previous trends you can see with turning it into an actual Trojan. You can manipulate the JavaScript that Discord uses because it's a packaged web app with the browser, and you can use it to control the different parts about the Discord app, or to scrape files like their tokens or even browser databases. And this is just a common trend you'll see with malware in general, especially the kind that is like with phishing scams, where you get an email like, hey, somebody's trying to access your RuneScape account. You need to update your password for your account. If like this wasn't you, click this link here. And of course you're like, not my RuneScape account. I've had that for like 12 years. So you panic and you click on it, and then that's how they drop malware onto your machine. And then hopefully either like Windows Defender, your firewall, or any sort of antivirus you're running catches that. So I mean, that's sort of a trend that you're seeing here, with especially like with trying to get people's saved credentials within like the browser databases. And you can see the I think this is the modified JavaScript.
Can you make that bigger?
Oh yeah, sure. Sorry, I forget. My monitor's kind of big, so it doesn't probably scale super well for you guys. Is that good?
Or I can probably still maybe zoom in a little bit.
Sure. And this isn't maybe immediately clear, but this is just sort of the JavaScript that you can use to get access to local file space. So you have the environment get folder path to environment special folder application data. And you have things like, this would be like your app data folder, and you have Discord local storage, and you can see here I think actually I can, oh, wrong one. I downloaded this thing from Mark Rasinovich, so you can it's a really cool presentation tool. So you can see that. So, come on, lay down. Sorry, that was my cat. So, you have these different credential databases used by the apps. And this could actually be sort of, if this was obfuscated, or maybe not in something in JavaScript or .NET where you can easily view, effectively source code. This is something that you could maybe look for in references in like an actual PE binary, and try to track things back and see what it is that they're trying to access. That's like the level DB string. Or in some cases, if they're obfuscating and you're trying to reverse a string, you might see different pieces like this. Oh, oops, there you go. So this isn't actually the one that we'll be going over today, but it's just sort of interesting to stay on top of the different trends and recognize what is happening in sort of the overall landscape. So this is another one that abuses Discord, and it's just another info stealing backdoor. And it talks more about how Discord is, Electron app, and a lot of its functionality is derived from basic web app stuff like HTML, CSS, and JavaScript. So what we'll actually be doing is talking about this one in particular again, which is the Abbadon RAT, discovered by Malware Hunter team. And if you want to download this, I have it right here. It's abuse.ch. But if you wanted to find this yourself, I mean, it's pretty straightforward. Usually you can just you can actually search for the hash, and if you're lucky, it'll pop up like right here. And I have an I have an easier way you guys can get this. you can just download it straight from the Google Drive we have. And I'll put the link in the chat, but that's just drive.malware.club. That's not here.
And of course, people will need to authenticate if you haven't authenticated before.
Oh yeah, right. I can go over that too real quick. So if you don't have internet access within your VM, what you need to do is you can open, I didn't bookmark this on your guys' browsers, and I probably should have, but you can open Internet Explorer or I think it's Edge browser now. But you can just type in captive portal, and you should see in the history there's an entry for this. You need to click the one that has port 6082 /php uid.php. Otherwise, and I can show you it won't go anywhere. Oops. At least I don't think it'll go anywhere. Yeah, so I mean, it's just loading, trying to get to it, but it was php uid.php ? Oops. That didn't work either. Yeah, there you go. So just click the one that's in your history. It'll be here, and you just use the same credentials that you use to log into the IA lab. You just click login, and that'll authenticate, and you'll have internet access within your VM. Oh, well, okay. Did not know that. Huh. Okay. Nope. Go on. Cool. Thank you, Neil. So do all you guys actually have internet access? I should probably check that before we get too far ahead.
I guess we can assume everybody does unless they speak up.
Yeah, if you don't want to speak, I think Zoom actually has like a yes or no option. That might be quicker so people don't talk over each other. There is, cool. Yeah, I'll just assume everyone has access. So yeah, back to how you can find samples. So if you're on Twitter and you see something interesting, usually most cases they'll post a hash. And I believe this is a SHA-256. You can just copy that, search for it. If you're lucky, you'll find entries like with the different sources like abuse.ch, or I think UnpackMe lets you download them. UnpackMe is a website where if you have a packed executable, like with UPX Packer, you can upload it to UnpackMe, and they'll actually analyze the binary, unpack it, and then give you the relevant files. And there's also Alien Vault. And then if you're fairly confident that it's been uploaded before, sorry, you can go to websites like VirusTotal or even Hybrid Analysis, and you can just do a search, use the hash, and you'll get this. And then I believe there's a option to download it. Should be. Otherwise, I might be misremembering.
I don't think VirusTotal does, but hybrid
okay.
Analysis usually does.
Yeah. Okay. Yep. That's the one.
But you have to have an account with Hybrid Analysis, though, or else they won't let you.
Right.
If anybody needs to get an account, I think you can do it with your school email address, or if they need more than that, I, as a faculty member, could always write you a letter saying that you're a malware student.
I think I've set up an account with them, and I don't believe they really get to gritty about it. So you can use any email you want to create an account, but if you want to get like elevated access to use their API, you would have to go to, I think it's profile, and then
could you make
vetting.
the text a little bit bigger?
Yeah, sorry. So you would go to, again, that's in the upper right. Once you've created an account, and logged in, you go profile, and then it's under this vetting tab. And it says right here, so vetted users can download files and ability to upgrade restricted API key access. So what that would do is, if I can find it here, I think it's this one. Yeah, so it shows you the different API requests limits that you can do. So I can do 200 a minute or up to 2,000 an hour, which is pretty cool. So if you're gonna like make your own, like, I don't know, Python sensors or something, you can actively like go out, check like the most recent like quick scans, or not quick scans, but it's under, yeah, file collections. So the most recent scans that people have uploaded, and then you can either download the results or the samples themselves, and you could like run it through Cuckoo or PE file, and whatever it is that you want to do. So it's a pretty good way to get like, I'm trying to think of the word, benign, and then also, so benign, like something that's not like overtly malicious and trying to exploit different aspects of someone's environment, versus something that is known malicious or has indicators that makes it very suspicious. Like, I don't know, like let's say your friend sent you a weird link from Discord because somebody's using it as a C2 and it's like a low-key bot. You could pull it from here if somebody's already uploaded it. Yes, that was kind of a rant. Nope, that's not it. Whoops. Where was it? Oh, and this was also sort of a tangent, but while I was looking for hashes and just anything related to this binary in particular, the Abbadon RAT, I found this website called Malshare, and it's like hybrid analysis, so it's just another source where you can pull malicious samples that people have uploaded. But you get like the MD5 hash, the file type, so portable, executable, data. So that's probably just like a raw binary stream or something that hasn't been classified. You can do zips, and you might also get like ELF for Linux or Mako for Mac OS. But you can upload it all here, and then you could just do like a quick search and see if they have it. Yep, so somebody's actually uploaded it here as well. Just do the captcha check, chimneys. Cool, yeah. I guess it doesn't have too many hits, but you get like the different hashes, some very basic file information and when it was added. But then they also do YARA rules. YARA is, it's like I'm probably going to butcher it if I just try to explain it from memory, but it's a pattern matching tool you can use. So what you do is you write these rules that try to match like maybe indicators of compromise or just general indicators of the binary itself. So the meta, this is just things that describe the rule itself. So maybe how dangerous it is, basic description, and then if you just, I guess, found it in the wild. And then you can use things like strings, where if it's based on this condition, if it has either string A, B, or C, then it's a match. And what this is doing is either searching for hex byte combinations, or not combinations, but I guess hex byte strings, or an actual like ASCII string. So it'll do that sort of pattern matching, and they can get pretty complicated. I don't know if maybe they have any like really good examples in here. Anyway, I mean, that was another sort of tangent, but it's kind of a cool thing to look into. And there are a lot of people who actually, they just go out and they create these rules manually by hand, and then a lot of different sensors or antiviral software, they use these too. So again, yeah, if you're just trying to find malware, this is a good one to do, and you could download it from here. And you don't need an account, I guess. Oh, no, you do need an account. Okay. But then you can download it from here through hybrid analysis. Like if you just search for it, create your account, you can download it. But to make things easy for you guys, I went ahead and downloaded it. So if you want, you can just kind of follow along. You can go to that drive.malware.club, and then it's going to be under the malbins folder, and it's this zip right here. So that's just drive.malware.club, malbins folder, and you can just right-click it and download. And I changed the password on it. So funny thing, kind of weird, kind of a good thing, but Google Drive will actively try to open the zips you upload and scan the contents. And if you use common passwords, like infected, for instance, it'll extract the contents, since it has a list of passwords it can use, and then it will, if it flags any of the archived files as malicious, it will delete your zip. So what we'll do is show on folder, and you'll have this here. You can just go 7-zip extract to this folder. The password is malware club, so same thing as the Zoom. And I'll just put that in the chat as well, just make things easy, I guess. You just click OK. I've already done it, so I'm just going to click yes to all. It'll create another folder, and that's weird. I don't know why that's there. But you'll just use this one right here, the 74F58. And like with anything, the first thing you want to do is just figure out what kind of binary that you're working with. You can just minimize this, put that window up there, and you're just going to open the Flare folder. And we're going to go to the utilities folder, and you want to use either something like exe info pe. You could use, I think Lord PE was another one. Nope, that's the editor. Yeah, I mean, I think you could use this one too.
Hey, Micah, could you change the resolution so that it's smaller?
Yeah, I'll do that. Here, maybe if I change the display size of my computer at all.
Yeah, I think that's probably what it would do, since I think it just auto fits to what you have.
There you go. This will be interesting. Yeah. I'm going to close that. That's kind of... Oh, this is going to be weird. I feel like my grandparents now. Just gonna... Cool. Just gonna make that a little smaller. So what you could do is... Oh, where was it? Like PE bear is one you could use too. I'm gonna make this thing disappear. There you go. That's better. So for this, you can just open the folder, grab the bin, and then just drag it over. And then it'll auto-populate everything. Okay, no, sorry, don't use this one. There's so many options that I'm actually confusing them. And just kind of exploring. Yeah, the one that we actually want to use is PEID, my bad. So again, just drag the 7.4F over, and you just kind of get some raw, like sort of static information about the binary. And you can do different things like multi-scan. That's actually for your directory. Or you can click these. You can see the different sections. The first bytes. But the best thing to do really is to just use multiple different ones, because they all work a little differently. So the next one maybe to use is exeinfo, and you can just drag the binary over. And really the interesting thing that we want to look at is right here, where it tries to identify the architecture of the binary. And it's saying that this is Visual C# basic.net, or MS Visual Basic. Or you can also look here and it says if you want to analyze this, it's .NET assembly, and you might want to use something like .NET Reflector. But if you remember from, I think it was either the second meeting we did, where we went over one of the how to use Flare VM, and with the Flare VM challenge from 2014, that was a .NET binary as well. So what you'll do is you'll go back out to the Flare folder, and you're going to open up the .NET folder and do dnSpy. So just want to mention it. It's kind of funny showing dnSpy for the first video, and just seeing how relevant a challenge from 2014 by Flare VM, or not Flare VM, FireEye, is to 2020, and looking at a piece of malware in the wild that somebody posted to Twitter. So what you'll do is you go open, or you can do Control O. Either one is going to take you to the same thing. Go to your downloads, and because the extension is missing on the binary, so you don't accidentally double click it and deploy malware to your analysis environment. You're just going to do all files, and then again, just do the one at the top, not the 7zip.exe. So double click that, maximize your window, just kind of make that a little smaller. And you have the binary right here, it's highlighted yellow. You just click it, and you can just, you can basically just explore a lot. So you can actually see why it's called Abbadon, and it's the I think this is the method name, and you can kind of just, if you want, you just double clicking, you can see just the overall structure for it. So the targets, models, you have things like credit card. You have you can see the data types they're using. So you have an encrypted value, the month, which is an integer, for the credit card, name, year. You can see, browser cookies, or Chrome database. So this would be pulling like passwords you're saving to your browser. This is why people say never use your browser to save passwords, because you can just dump it, and there are tools out there to, actively just decrypt dumped browser password databases. Another thing, if we have any gamers in the chat, they try to steal your Steam sessions. You can see, this is kind of interesting. I'm just going to close that. Just going to try to hide the taskbar so I can get a little more. Oh, okay, it won't let me. Whatever. Yeah, so this is one function that you can look at. And another thing that's kind of interesting is, in the past, like with that one flare challenge we went over, this is pretty easy to read, even if, you're not familiar with .NET, or, like the article that we were looking at earlier, JavaScript. You can kind of get a general idea of what they're doing, and they didn't even bother trying to hide it. So you're trying to get like the login from cookies, and you have trying to look for host keys like Steam powered, Steam machine auth, or even Steam remember login, which is another reason why people say, you should never save your passwords, or you should have like a dedicated device, and then you enter them in manually. And you can see references here, like directly to the steampowered.com to log in. So, they're just doing, I forgot the word, like for HTTP clients, where you can just manually make like the get or post requests. And you can see they're making the actual requests, and then using people's account information to log in. And sometimes what they'll do, like here, they're going through account history for balance information. So maybe getting things like, you can see here, like cookie, email, username, balance. You can go even further. So if you go, I think it's up to here, PE, wrong one. Should be a main function in here somewhere. usually you can just go from type references down, and you can find, oh, I think it's this one actually. Yeah, it's the program loop. And you can actually just, this is the really nice thing about dnSpy. You can just click, like on pretty much any element or like item within the block of code you're looking at, and it'll take you to, the location that's being referenced from, or even just looking at the data types for the executable. So like here you have a run loop, and it just goes here, and it like sleeps. I don't know if this is in milliseconds or seconds. So this is one of those things where like you'd have to track it. So like here it says sleep, and it has the delay, 60,000 times 2. So that's probably in seconds, I think. I don't know. That's not really something of really important interest, but if it's just kind of funny. So do 20 times 2 divide by 60, right? And that's 2,000 minutes, or divide by 60 again. And oh, don't. Yeah, so it's 2,000 minutes versus, that's just kind of odd. So every 33 hours, it will run the collect. And you go here, calls gc collect. And you have generation mode. It shows just all the different calls within the method. And then run. And it's creating a dump. And it's just actively going to search for, the different things like the Steam cookies, your general system info. You could click this one and just kind of look at what they're doing. So, they're getting like the country, your public IP. This is just sort of general stuff that you would find using like the system information. So the same stuff that you see there is what they're trying to exfiltrate back. You got things like username, computer name, language, country, public IP. So maybe from a sort of reverse engineering aspect, this could be kind of boring because you don't really have any heavy obfuscation. You're not really trying to reverse engineer anything, and you can kind of just read this.
Hey, Micah.
Oh yeah, sure.
Quick question. So when you said earlier to go to main, can you tell everybody? I know the answer, of course, but why are you going to main, or why are you going to the entry point? What is the purpose of a reverse engineer or malware analyst doing that?
Oh, sure. Yeah. So the main idea by going like to your program main is because you want to document the process from beginning to end, and you want to see what causes the piece of malware to be detonated or started, or and then what does it try to do as it goes from like A to B, and then like B to E. Is it dropping different artifacts? Is it trying to change things like registry keys? Like how is it trying to manipulate the victim's environment? And what things can you use to try to track like the behavior, or maybe the origin of where the malware was created? Like I think this might be something worth going over it's easy to find, like if you pop this open in, oh yeah, like right here. So registry utils, read registry. This would be the registry key. So like if you've ever used registry edit or reg edit, you can just go here. And they're trying to go to software machine, software Microsoft cryptography. So if I remember correctly, that'd be like local machine, and then they have software here, and you're doing Microsoft and cryptography. Yeah, so right here, the machine GUI ID. And so these are the sort of things that you want to keep track of because you want to know what kind of information is the malware targeting, especially if you're not just going at this from an analysis perspective, but also a recovery. So if like a piece of malware has been deployed, you want to know. I mean, usually people might just they have like a gold image and they just reflash a system, but you want to know what kind of information were they taking out, or if you need to fix anything, to make sure that there's no lasting consequences from that, initial compromise. Right, but the thing that I was going to show is, so kind of like with, in general, when you compile a binary, you can look at things like the PDB, and that's the program database. And it can include, it pretty much just includes a lot of compilation information about the executable. And you can find it under, like if you were to just pop this open in IDA or Ghidra, you'd see it pretty quick. I don't know how to find it under dnSpy. But basically what it lets you do is you could see where the file path for where the file is compiled. So let's say if I were in this folder and I had something like string.cpp and I would use like GCC or Clang to compile it, it would include in the PDB the file path for where that was compiled. So like if I were to click properties, you can't make that bigger. It would include the location. So you can see here, it's like C users malware downloads. And the neat thing about that is, that's an important indicator you could use, like for the YAR rules. You could say, well, if there is this string, C users malware downloads, that's a pattern you can use to maybe identify like malware virus variation or like familial connections. Like you could say, oh, well, this piece of malware has the same behaviors. It might be compiled differently, but there are also these like static indicators in the PDB saying that like this malware is compiled in the same location with unique strings. That might be a really good indicator for trying to match things by version, or just to say like it might have been made by the same author. And you see a lot more of that when you're looking at like on Alien Vault. Here I'm kind of jumping around a lot. If you guys have any questions, you can totally just stop me. Like you can go Alien Vault, OTX. It's kind of this is kind of a neat website if you haven't used it before. It's not just for like businesses trying to like add threat indicators, but if you get into the whole malware analysis scene, you can go here and you can see things like APT threads. So that's advanced persistent threat. That could be, I think, things like like North Korea, any like hacking organizations that are connected, that sort of government entity, sort of organization. That can be classified under like an APT, and you can track that here. So like here, APT 16. Let's click this one, WikiWorm. Yeah, so generally, I mean, you can just get things like here, you see you have a file hash here for macro malware. You can click on it again, and you get sort of the analysis overview, and that includes anything like just the basic static file information, hashes, the date it was compiled, any sort of external domains referenced within the binary or ones that it tries to connect to. And here you also get like Suricata. I think this is Suricata alerts, and these can also be created using, again, YAR rules. See if there's anything else in here maybe to mention. Yeah, and here, so these are, so this is going to be like a behavioral thing. These were the HTTP requests generated when this program was ran. And you get things like interesting strings. So this isn't necessarily maybe anything that's immediately helpful. Sorry, that was kind of annoying. Then you also get different things like, again, the PE sections. You could use things like PE imports, the APIs and the different functions used by the program. Those are all things that you could use for fingerprinting or any sort of like instructions or bytes that are really unique and interesting to that program, or maybe the pattern that they're called in is also something you want to look at. So that's just kind of a lot of information, but gives you the idea of why you want to go through this process of understanding how everything connects together, and then what it sort of means for the end result of building like a report and understanding what it is that causes the program to start, when it ends, and everything that happens in between.
Earlier, you were showing the imports and the modules.
Sure.
Can you explain how they relate to MPash for everybody?
Sure. That was MPash.
Yeah, just explain how those are used to create an MPash.
Oh, sure. So, like if you're doing MPash, something you could do is you have a hash for the API function, and sometimes you have like, so this is like a handle or a name, and this is referenced by the program, like in the, I think it's the IAT, which is the import address table. And you can, so typically like the program, the way it gets these imports is you have the name for the function you want to get, and you use something like get proc address or get handle address, and it'll return an offset or an address within that binary to the location for like this DLL. And then within that DLL, there's a data structure called the it's the PEB LDR, I think. And within that, you also then get all of the functions referenced within that structure. And sometimes, there are a lot of methods for obfuscating the imports used. So you could actually, like they'll hollow out the import table, and then they'll use like functions limited maybe only to kernel 32 to, or I think it's mostly just kernel 32, but they'll hollow out the import address table, use the kernel 32 DLL to sort of hash the functions and reference them within maybe a different section of the program, so that the typical static methods you might use to just dump the imports from the IET, they're instead hidden somewhere else within another section that the program doesn't know how to read. So it uses these hashes to reference the different section location sort of dynamically throughout the time that the programs run. And it's another thing where maybe you wouldn't be doing static analysis unless you're going to manually uncover the hashing process by hand. And you might have to do things dynamically, like actually running it and reading things from memory. Is that sort of it, or did I go in a different direction?
I think you maybe misunderstood my question. I think you were taking it more from the standpoint of using peb walking and hashes for strings to load functions in a kind of secretive fashion. I just meant explaining how the imp hash algorithm, or not algorithm, but the imp hash is created.
Mm-hmm.
Like SHA-256 and that type of thing.
Oh, so like just dumping the imports and then creating a hash from it?
Right, yeah.
Oh, okay.
That's all I just wanted you to say.
Yeah, so actually that may be something a lot more simple. So, if you just dump the different imports, from IAT, you can create something like Brisbane just said, a imp hash, where you, in the same way you might use like a MD5 up here, and you would identify like a string. What you would do is I can actually like show that probably. So let's say you copied all of these imports from the IAT. You would then use like a MD5 hash function, and then you would create like a imp hash off of those imports. So now we've simplified all of these functions that were called under kernel 32 into this hash. And then what you can do is you can compare those import hashes against hashes generated from other binaries. And you can try to say, well, if you know that this other sample has been used to do like ransomware, then it might also be used for ransomware because the hash is so similar to the known hash of a piece of ransomware. So that's just another way that you can try to identify binaries.
I think it's also important to mention that one piece of one ransomware may use certain functions. Another ransomware may use the same DLL, but it may use 3 or 4 other functions, and so therefore the hash would be different, even though they're both ransomware and they're both using the same DLL.
Mm-hmm. Yeah, that's a good point. Another thing is like if you're relying solely on the imp hashes to identify whether something's malicious or benign, it's possible that a piece of malicious software and a piece of benign or non-malicious software use the same DLLs or functions, but the purpose is different. So one is trying to actively like encrypt your hard drive so they can ransom it for money, whereas the non-malicious software is encrypting it so you can protect your files from malicious actors. So, and that's where sort of the dynamic analysis part comes in, because you need to also understand the behavioral aspect of malware. So that's that. And then that was a really long tangent. Oh yeah, we were trying to look at the PDB for the compilation path. I'd have to look it up. Maybe I could just share that with people after the meeting. But it also just goes to show just how cool the dnSpy program is, because there's sort of an equivalent tool to dnSpy. I mean, there's .peek, there's ILSpy. They're all pretty good. I've had good experiences with dnSpy, but then after school, if any of you actually do this in your career, something you might see is I think it's .NET Reflector, and that was mentioned by that piece of software we were just using. Forget what it was called. Oops, wrong folder. I think, what was it that we were using? Yeah, exe info PE, I think, where you opened it and it said, for further analysis, use .NET Reflector. That's sort of what this is. Or you also have, .NET Reflector. And it's essentially the same thing as dnSpy, and it's just a decompiler for .NET code. And it, effectively lets you look at the program in the same way as it was when it was compiled from source, to an actual executable. I've never used it, so I don't actually know how different it is. But if you got bored, or if you ever had the opportunity, it would probably make an interesting project to explore. Otherwise, I mean, we can kind of just maybe wrap up the meeting real quick, but we'll just look through the rest of the main function, just get a general idea for what it's doing. That was run loop. We'll try to run it, catch any exceptions if it doesn't work, and then it continues to just sleep for 33 hours and repeat. And you get down here, you have the Steam cookies. Don't know what this one is. Oh, okay, I see. So it starts whatever the task is, and I guess it gets tasks from here, so it just starts whatever it does. Then it waits, and then it clears them.
Looks like it's maybe doing it in parallel too.
Yeah, I think there should be a list in here of like the tasks that it has built. And this, is, it's reverse engineering and it's malware analysis, and just because it's not necessarily obfuscated, so it may not be as interesting to solve. I guess you still have the maybe as interesting task of just going through and seeing how everything flows from beginning to end. So I believe when I looked at this earlier, and then from some of what I read before, the tasks that it creates are just the different targets, like for targeting like Chrome. And I think there was even a portion where, because it's JavaScript, it would, and if you're using Discord and you click on a message, it'll say you read it. It'll actively go back and change the read history as if the rat, never looked at it. Yeah, this is an interesting one. So you can even steal like the MFA key, or you could change it. And that's, multi-factor authentication. You can get people's phones, their usernames, the token for their account. And it gets even more interesting when you realize that, you can, I guess, I don't know how much people use Discord, but if you're a server or Discord host, you can create bots, and then based on activity within the Discord channel, you can have the bots respond. Oh, dang. Jeremy had to drop off early. Okay. Should have said bye. Oh well. Yeah, so if the Discord bot sees like certain activity, you could actually have it trigger events within the channel that this rat is going to be monitoring. So I think if I can find it here, it should be under either the Discord envelope or in one of the targets, where it should show the tree, not tree, but the channel that it's connecting back to. Yeah, so this is looking for the MFA for multi-factor, and then you'd probably have to run this within the Discord log folder to see what pops out, for the regex matches. Because just immediately off the top of my head, I do not know what this does, and I haven't read any reports from anyone else, about this specifically. Oh, and this is really interesting. This I saw mentioned on some, a lot of the different analysis reports. Apparently there is a ransom functionality built into the RAT, and I think the idea was that people were saying, after a certain amount of time, you're probably going to see this get detonated from the Discord C2, assuming it doesn't get shut down beforehand, and everyone's machines are going to get locked. And you can even see, maybe it's under here. Yeah, format, blah, 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 BTC. And then there's a how to encrypt txt. So all this is going to be written to that text file with directions telling them what they need to do. So supply the master key after payment if you're savvy enough, DIY it. And then, so it's going to encrypt it maybe after a certain amount of time, or if the command is sent out from the Discord C2 channel telling this to encrypt, and then, when the user either reboots, or maybe if the rat forcefully causes it to reboot after being encrypted, they'll see this on their desktop, and it'll be like the only thing that they have read access to, and everything else is locked out from read-write access for their user. That's a common thing you see. And what they'll have to do is they have to, send whatever the BTC amount is to their address. And this is just more of the information. So I think just looking at this, what it does is, so these are some of the tasks it uses, and it connects out to the Discord C2, and it gets the address. So it's not actually stored in here. So what you'd have to do then to maybe take this a step further before, understand just, simply that, oh, it's being ransomed and this is how they're doing it, you'd have to find the link to the Discord channel, which, and I didn't spend too much time just going over this before, but I didn't see the actual Discord link, beyond just the API there. Does anyone have any questions so far? Just, kind of looking through this, like maybe about dnSpy or about how maybe malware like this even gets uploaded to Discord in the first place? That's okay if you don't, but yeah. So I saw people talking about this in particular. So for a while, Discord didn't actively have any sort of measures for making sure that what people were uploading wasn't malicious or like a virus or like Trojans or especially like this one in particular, RAT. And just recently, I suppose, maybe within the past year, they set it up so if you upload something, it's going to be compared against like known hashes of malware. So people can't upload things that are already been recognized as malicious. So something like this wouldn't be able to get uploaded again. But if it had been uploaded before those rules were set, it's still going to be available from Discord as sort of like a attachment that you can look at. And you can see that, I'm just going to zoom out a little because that's way too big. See if it's in here somewhere. I remember reading it. Well, either way, I mean, you can't upload anything new that's known. Oh yeah, so right here. So if something was previously uploaded to Discord, and at the time they didn't have any rules in place to detect it as malicious, it's still up there and you can still get to it, and they haven't actively tried removing it. So it's kind of funny that existing malware, unless maybe these Discord, attachment URLs have been attached to those YAR rules, you can still use Discord as a CDN to distribute your malware or previous malware that people have created. And it's especially really evident if you think about it. So this Discord RAT is new, and it wasn't something that was detected before. It was being propagated in the wild. So from that standpoint, it's probably still on Discord and being hosted. You'd have to know first the this first part of the link though to actually find it. We know the file name is, well, we know what it was when it was compiled. You can see it in dnSpy, and that's just up here. Oops. Yeah, INDSV. Oh yeah, I should have mentioned that. So you can find the entry point up here. So when you click on it at first, it's under the entry point, and then it's abandon program main. You can just click. It takes you here. You do the run loop, run, and then you're pretty much in the full functionality of it. But now we've gone on for like about an hour or so now, and I think that's most of what I have to talk about. Well, I mean, that is pretty much everything I've talked about today. Did you have anything you wanted to talk about, Bramwell, or?
No, nothing really comes to mind.
Okay. Were there any reminders maybe for that hackathon? Um,
I think that's still under development, but I think that they're still checking to see if they can, I think, get cash to pay out, or if they can't do cash, they may do gift cards. If they, for some reason, business office isn't going to let them do cash or gift cards, then it just may have to be for nothing, except maybe bragging rights. But I think they're going to go forward with it. It's just to be determined, and I think it's like I mentioned before. It'll be, I think, sometime in early December, then extending all throughout the Christmas break.
okay, cool. And then do you think they'll put out an announcement for that in like DCU activities or?
Oh yeah, the dean, Dr. Ingebretson, who wrote a popular hacking book. Anyway, he even last 2 weeks ago when he first mentioned it, he already had a poster created. So I think they'll definitely put posters and stuff out.
Okay.
But if you're online, then you probably won't see posters. So I'm not sure how you will find out, but I'm sure we'll probably meet again before then, and I'm sure word will get out to us somehow.
Yeah. I guess if they don't put it in the DSU activities post, when we hear about it, I'll put out in one of the weekly, bi-weekly emails that we do.
It sounds good.
Cool. So I guess that's it. And we'll see everyone again in.
Or does anybody else have any updates or anything that they want to share? Or?
Oh,
Other than, I guess, for this being my first one here, not bad. I liked it. Pretty good stuff.
cool. Glad that you liked it. If you have any ideas, maybe for things that you want to see in the future, you can just contact myself or Bramwell, and we'll see what we can do. Cool. Well, that's pretty much it then, and I guess we'll see everyone again in 2 weeks.